Now we're doing implicit differentiation, and this is a bit of a different one. This is example 1b. Notice in this one, instead of having a y squared, which you often find in an implicit differentiation question, we've got an xy term. And that's our little bit of a trickier part. So it's going to be the tricky part of this one. We start off, we want to derive it. dx xy equals dx 2x plus 1. The right-hand side, the derivative with respect to x will be 2. So that's simple where we want to go with that. The problem with the left-hand side, it's a bit harder, isn't it? What are we going to have here? Now we're going to have to use product rule. I'm going to go over here and say we want to derive, just because I have more room over here. Oops, sorry, I didn't have, so you can see it. We want to derive. Now remember when we derive product rule, I'll leave the x and then I'll derive the y, plus then I'll leave the y and I derive the x. So I get x dy dx plus y times the derivative of x with respect to x is just going to be 1. So putting that back over here, I've got x dy dx plus y equals 2. So that's x dy dx equals 2 take y, dy dx 2 take y over x. And there's our derivative. So the key point with this one is when you want to implicitly derive x, x, y, we're using product rule. We substitute it back over.